Welcome to Cambridge IGCSE Physics, Lesson 38.1, What is Resistance? Today we explore electrical resistance, a fundamental concept in physics. Resistance affects every electrical circuit and device around us. Understanding resistance helps explain how electricity flows through materials and why some materials conduct better than others. This lesson forms part of the core content for Cambridge IGCSE Physics Specification 0625, ensuring you master essential concepts for your examinations. Let's examine our learning objectives for today. By the end of this lesson, you will be able to, first, recall and use R equals V divided by Y for resistance. This fundamental equation connects voltage, current, and resistance. Second, define resistance as opposition to current flow. This definition explains why some materials allow electricity to flow easily while others resist it. Third, understand that resistance is measured in ohms, named after German physicist Georg Ohm. These objectives align with Cambridge IGCSE assessment objectives, focusing on core knowledge and practical application skills. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, resistance, pronounced resistance, means opposition to electric current flow. Think of resistance like friction for electricity. It opposes the movement of electric charge through materials. Second, ohm, pronounced like home but starting with O, is the SI unit of electrical resistance, where SI means International System of Units. 1 ohm represents the resistance when 1 volt produces 1 ampere of current. Third, current means the flow of electric charge measured in amperes. Understanding these terms precisely is crucial for mastering electrical concepts. Let's explore our first core concept. What is resistance? The fundamental principle states that resistance opposes current flow in electrical circuits. This means materials naturally resist the movement of electric charges through them. The definition is, resistance is the opposition that a material offers to the flow of electric current. Some materials like copper have low resistance, allowing current to flow easily. Others like rubber have high resistance, blocking current flow. Mathematically, we express this as R equals V divided by I, where R represents resistance measured in ohms, V represents voltage measured in volts, and I represents current measured in amperes. The circuit diagram illustrates a simple example with a 6-volt battery, 3 ohm resistor, and 2 ampere current. Notice how R equals V divided by I gives us 6 divided by 2 equals 3 ohms. Now we examine the experimental method for measuring resistance. This follows Cambridge IGCSE standards. The apparatus needed includes a battery to provide voltage, a resistor to measure, a voltmeter to measure potential difference, an ammeter to measure current, and connecting wires. The method consists of these steps. First, connect the circuit with the voltmeter in parallel across the resistor. Second, connect the ammeter in series with the resistor. Third, record voltage and current readings. Safety is paramount. The hazards include electric shock from high voltages. Therefore, you must use low voltages only and check all connections before switching on. The diagram shows the complete setup with voltmeter measuring voltage across the resistor and ammeter measuring current through it. Let's work through our first example. The problem states, a resistor has 12 volts across it and 3 amperes flowing through it. Calculate its resistance. We are given voltage equals 12 volts and current equals 3 amperes. We need to find the resistance value. Step 1. Write the equation. We use the resistance formula, which is R equals V divided by I, where R is resistance, V is voltage, and I is current. Step 2. Substitute the values. We write R equals 12 volts divided by 3 amperes. Step 3. Calculate. 12 divided by 3 equals 4. Step 4. State the answer. The resistance is 4 ohms to appropriate significant figures, with units of ohms. Example 2 applies the same principle differently. The problem is, find current when voltage equals 9 volts and resistance equals 3 ohms. The data shows we have voltage of 9 volts and resistance of 3 ohms and we need current. Now we analyze. First, rearrange the equation. Starting with R equals V divided by I, we need I, so we multiply both sides by I and divide by R to get I equals V divided by R. Second, substitute values. We write I equals 9 volts divided by 3 ohms. Third, calculate. 9 divided by 3 equals 3. Fourth, the current is 3 amperes. The graph shows the linear relationship between voltage and current for this 3-ohm resistor, demonstrating Ohm's law. Mathematical skills are crucial in physics. Let's examine 3 key skills. First, equation rearrangement. When we need to find a different variable, we rearrange algebraically. Starting with R equals V divided by I, where R is resistance, V is voltage, and I is current. To find voltage, we multiply both sides by I to get V equals I times R. To find current, we multiply both sides by I and divide by R to get I equals V divided by R. Second, unit conversion. To convert from milliamps to amps, we divide by 1000. So 1000 milliamps equals 1 amp. To convert kilovolts to volts, we multiply by 1000. Third, significant figures. Match your answer precision to the precision of given data. If data has 2 significant figures, give answers to 2 significant figures. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, calculate R when V equals 6 volts and I equals 2 amperes. Use the formula R equals V divided by I. Question 2 is intermediate. It states, find current when V equals 15 volts and R equals 5 ohms. This requires you to rearrange the formula to I equals V divided by R. Question 3 is advanced. The question is, a lamp has resistance 12 ohms and current 0.5 amperes. Find voltage. This tests your ability to use V equals Y times R. For all questions, remember to show you're working clearly, include units in every step, and check your answers make physical sense. Physics principles power our modern world. Let's see how resistance applies in practice. In electronics, resistors control current flow in circuits. Every electronic device from smartphones to computers uses resistors to ensure components receive correct current levels. In heating applications, electric heaters use high resistance elements that convert electrical energy to heat energy when current flows through them. In safety systems, fuses contain materials with specific resistance that melt when current exceeds safe levels, protecting circuits from damage. These applications show why understanding resistance matters. Career-wise, electrical engineers design power systems, electronics engineers create circuit boards, and telecommunications engineers develop communication networks. The resistance concepts you learn today become tomorrow's technological innovations. Let's review the solutions. For question 1, the answer is R equals V divided by I equals 6 volts divided by 2 amperes equals 3 ohms. This is correct because we applied the resistance formula directly. For question 2, we find I equals V divided by R equals 15 volts divided by 5 ohms equals 3 amperes. We rearranged the formula correctly to solve for current. For question 3, V equals 1 times R equals 0.5 amperes times 12 ohms equals 6 volts. Notice we used the rearranged formula for voltage. Now, exam success tips. First, always show you're working step by step. Even if the final answer is wrong, you earn marks for correct method. Second, include units in every calculation step. Third, check if your answer is reasonable. If you calculate impossible values, review your work. Fourth, read questions carefully to identify exactly what you need to find. Let's summarize today's lesson. The key points to remember are, first, resistance is the opposition that materials offer to electric current flow. This fundamental concept explains why different materials conduct electricity differently. Second, the formula R equals V divided by Y connects resistance, voltage, and current, with resistance measured in ohms named after Georg Ohm. This equation allows us to calculate any unknown when we know the other 2 values. Third, applications include electronics where resistors control current, heating systems that convert electrical energy to heat, and safety devices like fuses that protect circuits. These 3 concepts form the foundation for understanding electrical circuits. For further study, practice rearranging the resistance equation to solve for different variables. Review unit conversions between different scales. The next lesson covers factors affecting resistance, which builds on today's work by exploring how material properties influence resistance values.